the data. What happens if you are deploying a smart contract? As you remember back, the first block of the blockchain is the Genesis block, and then from there new blocks are generated and they are pointing back with the hash of the previous block to always the block that came last. So when you have the block 1, it points back to block 0, so you can't change that one. Block 2 points back to block 1 with the hash of block 1, so if you can't really change that one, and so on and so forth until you hit a certain block height. Block n might be block 6000 or block 60,000 or any block number after the Genesis block, and there you are right now at the moment, and then you write your smart contract and you deploy it onto the blockchain. So what happens there is you compile your smart contract into the EVM bytecode, and this EVM bytecode gets baked into a transaction as the data field in the transaction, and the transaction is sent off to the network. And then this transaction is in the block N once the transaction is mined, and this block is distributed across all the nodes in the network. And then from there it goes on with block n+1, and then n+2, n+3, and so on. So it's always there. So why is it impossible to delete data? Shouldn't be any surprise anymore. So as you know, the block 1 points back to block 0, block 2 points back to block 1, and block 3 points back to block 2. In our transaction example, maybe we have one transaction where we deployed our smart contract in block number 2 and nothing else. So we want to delete our smart contract, and if we want to delete the smart contract, we would have to undo the transaction and basically totally remove block 2 from the blockchain. But that is almost impossible, because we would have to link block number 3 back to block number 1 and basically take out this whole block with the transaction so that it basically never happened. The problem with this is the blockchain and the data is distributed across all nodes of the network. So when you start a blockchain node, then it will start downloading all the blocks and rescan the blocks for the content and build up the so-called state or state tree. So the blockchain node will start downloading blocks 0, 1, 2, 3, 4, 5, and so on, and will go through these blocks and recreate its own state through going through the transactions that happen in the block. The problem is with taking out one of the blocks is that you would have to remove this one block on all of the nodes across the network, and that is simply not possible in the current implementation of the blockchain, and it's not meant to be, because data has to be immutable. Once deployed, it cannot be changed. This is a property of the blockchain, and it's actually a very good property that you don't want to change. So if data privacy becomes an issue for your organization, but you still want to use blockchain for specific solutions, then one solution to that problem might be not use a public permissionless blockchain like the mainnet. Maybe set up your own consortium blockchain inside your corporation where data privacy or the immutability of the data isn't an issue anymore. Then we are talking about starting and stopping smart contracts. There's a smart contract lifecycle. It starts with actually creating the smart contract. You write the Solidity code, you compile Solidity down to EVM bytecode, and you send off a transaction. This is where it starts running. So as soon as the transaction is mined and baked in a block, you can start interacting with your smart contract. The smart contract gets its own address. The address is deterministic. It's not a random address. We are talking about this a little bit later. And you can send transactions to that address that is containing the smart contract data. And then you can stop a smart contract. You cannot remove it completely. So it will always be, anybody will be able to audit everything that happened with the smart contract. But at the time you start calling self-destruct, you can only call it once. It gives the blockchain the instruction to stop and remove the smart contract from the state. When you deploy a smart contract, then in the transaction, the compiled bytecode is filled into the data field. So this one will contain the bytecode, and the to field will be empty. So if that happens, if a transaction is sent to the network with this kind of configuration, then the blockchain node that is mining the blocks will know this is empty, this has data, this means this is a smart contract, let's put it into a block and mine it and give it its own address. And then you can interact with it. It also happens all with transactions. As I said before, every single interaction with the smart contract is transaction-based. You send it to the smart contract address. The data field is populated with a specific encoded function call and function arguments. We are talking about this in the debugging lecture a little bit more. And in addition, you can send value to the smart contract. We've done this with the smart contract receiving money. So in the to field was our smart contract address. In the from field was our account that we selected from the accounts dropdown. The data field, I didn't really explain the data field yet because it's a little bit too early in the course. And the value, you've seen that when you send Ether to a smart contract, then the value field is populated with the value in Wei, which is the smallest denominator. 1 Ether is 10 to the power of 18 Wei. And then when you destroy or stop a smart contract, we had this function which calls self-destruct. And when you call self-destruct, self-destruct takes one argument, which is the address of the person that gets the remaining funds stored on the smart contract address. After that, the smart contract will not be available anymore for interaction. If you can always go back in the blocks and see what was there, but going forward, a state is built up by going through all of the blocks, and usually you want to reach the state by processing all the blocks until the latest block, and then in the latest block there is the smart contract not anymore inside, or in the latest state the smart contract is not anymore inside because it's somewhere you called self-destruct. So this would stop or destroy a smart contract. What are the key takeaways? Let me recap this a little bit. The smart contract gets compiled and sent to the blockchain as a transaction. Everything is transaction-based. The transactions cannot be undone. If they are successfully mined, they cannot be undone. Transactions are atomic operations, so when they fail, it looks like as if nothing happened that was ever in the transaction inside. And immutability means that you cannot delete data, you can only change the state from, or the current state that is in the latest block. Yeah, and when you destroy the smart contract finally after running, then you cannot interact with it anymore.